Hello, welcome back to our channel, and this time we have brought to you a very interesting topic about the dancing light. In technical terms, we call it as a LED, that stands for light emitting diode. So it's simply a PN junction in a semiconductor theory, and we know that how the diode works. It's a PN junction. It has two terminals such as anode and cathode. However, this special diode emits light when it is conducting a current through it. Okay, so when it is forward bias, it emits lights, and it emits lights in different colors. So we will see when it emits a particular color of light, what is the science behind it. For example, you see here in the schematic, this is a light emitting diode. One lead is termed as anode, second lead is termed as cathode. Anode is usually long lead and cathode is a shorter. All right, and here the internal uh, annotations indicate the different parts of this device. So for example, this glass cover that looks like is epoxy or a case. Then there is a wire bond uh, that is shown right here. And here is the semiconductor die, which actually is responsible for the operation. So coming back to our topic, we see that beautiful colors of light emitting diodes when we make it conduct, such as blue, red, and green. And it is also infrared that is not visible by the eyes. So what we see from this table is the different colors, including infrared. And when it emits the particular color, it means it is in the particular wavelength, which is in the electromagnetic spectrum. So electromagnetic spectrum relates the wavelength to the frequency, okay, and to the waveform, to the signal, electromagnetic radiations. So for example, if your light emitting diode is infrared LED, so by visible eyes we cannot see the color of a light, but it is still conducting a signal through it. So it is usually in the wavelength range from 940 to 850. And when, like any PN junction, when it is forward bias and conducting a current through it, LED also will conduct a current through it, and it will get a voltage drop across it called as forward voltage drop. By the color, it is ranging from 1.1 to 1.7. If your light is red, then you can say the signal, electromagnetic signal, is in the range of 660 to 620 nanometer wavelength. And the forward voltage drop for the color red is about 1.7 to 1.9. If you have an orange or yellow color LED, your wavelength is 620 to 605, and the forward voltage drop is 2 to 2.2. For the green, the wavelength is decreasing from 570 to 525, and the forward voltage drop is 2.1 to 3. It is increasing as compared to the previous one. And finally, if your LED is a blue or white color, it is in the wavelength of 470 to 430 nanometer, and the highest voltage drop that you'll get is from 3.4 to 3.8. So you see, from by color wise, from infrared to the blue light, your wavelength is the highest for the infrared and the lowest for the blue or white light. And the voltage drop approximate is the lowest for the infrared and the highest for the blue or white color LED. So that's the magic for this LED, because this is a fundamental science that we need to know. Of course, we will use the LED, we will make it forward bias and make it conduct, and it will emit a light for our circuit and applications. But we should know when it is emitting a light of a particular color, whether it's visible to the eye or not, it is emitting an electromagnetic waves. It is transmitting that signal. So we should know from the electromagnetic spectrum in what range it falls, and that is decided by the wavelength. And you can also calculate the frequency range of that signal. Similarly, the lowest to highest voltage drops is important for the LED to conduct. So hope you enjoyed understanding the fundamentals of the lights, optics, and the LED. If you like the video, click the like button, comments on it, and do share with others for wider reach. Till then, stay tuned. I wish you happy learning.